Assalamu alaikum everyone. Welcome back to my channel. Today we are going to start 5.6 magnetic force. Magnets are all around us. From refrigerator doors to powerful industrial machines, they play a crucial role in our daily lives. But how do magnets work? What makes them attract or repel? In today's video, we will explore the fascinating world of magnetic forces, understand the strength of magnets, and see how they interact with each other. So let's get started. Getting started. What is the difference between a magnet and a magnetic material? Complete these sentences for your answer. A magnet is a material that has an area around it where magnetic force is active. In this area, a magnet can attract or repel other magnets, and it can attract a magnetic material. A magnetic material does not have an area around it where magnet force is active. So, a magnetic material cannot repel or attract another magnetic material. Forces between magnets. Arun is holding two magnets so that they can swing freely. If the unlike poles are facing one another, the magnets are attracted to each other. This shows the magnetic force of attraction between them. Arun finds that the magnets are attracted to each other when they are still a distance apart. This shows that the force between magnets can act over a distance. Remember that a magnet is a material that has an area around it where magnetic force is active. So as long as Arun holds the second magnet inside this area, the two magnets will be attracted to one another. The stronger the magnets, the bigger the area and the bigger the distance can be. Strength of magnets. Magnets can be extremely strong. Look at the maglev train in the photograph at the start of this topic. This high-speed train uses magnets to work. Scientists have used their knowledge of magnets to invent trucks that are made of very strong magnets. The train floats above the tracks. We will work with much weaker magnets in class. Let's investigate how far apart a magnet and a magnetic material can be for the magnetic materials to be attracted to the magnet. We are going to compare different poles of two magnets to see if some magnets or poles of magnets are stronger than others. Think like a scientist. Test the strength of magnets. You will need two different magnets such as a bar magnet and a horseshoe magnet, a metal paper clip with no plastic coating, a 30 centimeter plastic or wooden ruler. Your ruler remains in the same position during the activity. Place the paper clip at the zero end of your ruler. The position of the paper clip is dependent on changes of the magnet. We are going to measure these changes. Place the north pole of magnet 1 at the other end of your ruler. You are going to change the magnet during the activity. Slowly move your magnet towards the paper clip. Stop the magnet as soon as the paper clip is attracted to and touches the magnet. Read off the distance in millimeters on the ruler. Record the distance on your table. This is the first reading. Repeat to find a second and third reading for the north pole of magnet 1. Carry out the activity again with the south pole of magnet 1. Fill in the table. Repeat the activity to test the strength of your other magnet. Calculate the mean readings and fill in the mean reading column of the table. To calculate the mean reading, add together the three readings and divide the sum by 3. For example, if your three readings were 3.2 mm, 3.4 mm, and 3 mm, the sum is 9.6 mm and the mean reading is 9.6 mm divided by 3 is equal to 3.2 mm. Draw a bar graph to present your results. Use the mean readings. Use a scale of 1 centimeter represents 5 mm. Draw a bar for each pole of each magnet. Give your graph a suitable heading. The table has been filled it with you. The reading have been measured and entered in this along with the main reading. Question answers. Why can't you use a steel ruler for this activity? Steel is a magnetic material, so the magnet would attract a ruler. Why did you use a steel paperclip? Paperclip is a magnetic material. How did this activity show that forces between a magnet and a magnetic material act over a distance? Magnet attracted the paperclip when it was some distance from the paperclip. Were the three measurements for each magnet always the same? No. Why is it good scientific practice to take each measurement more than once? To get more accurate results. Were the strength of the north and south poles of each magnet different or the same? Probably one pole is often stronger than the other. What did you do to make sure your test was fair? Keep all the variables same. Identify the control variable and the dependent and independent variables. Independent variables. What you change? The type of magnet, bar magnet or horseshoe magnet. Dependent variable. What you measure? The distance at which the magnet attracts the paperclip. Control variables. What stays the same? The ruler's position, the type of paperclip, the environment. Why did one of the magnets attract the paperclip from a greater distance away? The stronger the magnet, the larger the region of magnet force it has. This means it can attract objects from a greater distance. What do you conclude about whether or not magnets can have different strengths? Magnets have different strengths which depend on their material size and shape. Which type of science inquiry did you practice in this activity? Comparative testing, measurements, and observation. Check your progress. Match up each word 1 to 5 with its meaning from A to E. Word meanings. Gravity. D. A force which attracts all the objects towards the earth. Magnetic material. C. A material that is attracted to a magnet. Applied force. E. A force that is attracted to a magnet. Alloy. A. A mixture of metals. Satellite. B. A body in space which moves around a larger body in space. Identify the type of force acting in each of these pictures. It's gravity. The type of force acting in the picture is gravity. Gravity is the force that pulls objects towards the earth, keeping the children standing on the ground. Even though they are not moving or applying any visible force, gravity is constantly acting on them to keep them from floating away. Which of the following materials are magnetic and which are non-magnetic? Steel and iron are magnetic. Wood, copper, plastic, and aluminium are non-magnetic. Copy this picture of a submarine. On your picture, label the 4 forces which act on the submarine when it is moving through the water. Show the direction and name of each force. When the submarine is at rest, which 2 forces are acting on it? When the submarine is at rest, the 2 forces acting on it are upthrust, upward force. This is the force exerted by the water pushing the submarine upwards. Gravity, downward force. This is the force pulling the submarine down due to its weight. What causes the thrust? Thrust is the force that moves an object forward, created by engines or propellers. Describe the submarine shape. A submarine is long, cylindrical, and has a pointed front. Why does a submarine have this shape? A submarine shape reduces water resistance, making it faster. Arun and Marcus are comparing the strength of two magnets. They are using a plastic ruler and a steel drawing pen. Why are Arun and Marcus using a steel drawing pen? To test the magnet's strength, as steel is magnetic. Why are they using a plastic ruler? To avoid affecting the results, as plastic is non-magnetic. What is the control variable in their investigation? The type of ruler and drawing pen. What is the dependent variable? The number of drawing pens each magnet can attract. What is the independent variable? The type of magnet. How does the investigation show which magnet is the strongest? By counting how many pins each magnet picks up. I hope you found this video helpful. Let me know in the comments where have you seen magnets being used in real life. See you in the next video. Take care. Allah Hafiz.